Welcome to Lab M2, Equilibrium of Forces. The objective of this lab is to verify the vector addition of forces. You will be using circular horizontal table with a 360-degree scale, pulleys, weight hangers, slotted weights, a protractor and rulers. For a system to be in equilibrium, the sum of all forces has to be zero. Force is a vector quantity. Vectors can be represented by arrows, where the length of the arrow is proportional to the magnitude of the vector, and the direction indicates the vector's direction. To calculate the vector sum graphically, you can use the tail-to-head rule. You begin by constructing a parallelogram by either shifting A or B such that the tail of one vector is on the head of the other vector. After that, simply join the endpoints and you will get your resultant vector. To numerically compute the resultant vector, first resolve the two vectors in their x and y directions. To get x and y components of the resultant vector, simply add the x and y components of vector a and b together. You can then easily calculate the magnitude and direction of the resultant vector. To verify if the vector addition really works or not, first choose two concurrent forces each between 100 and 500 gram weight. Then use both graphical and numerical method to get the resultant force. Check your result by setting up the two original forces on the force table and finding experimentally the single force which will hold them in equilibrium. You can then remove the pin which was earlier holding the weights in place to see if the system is stable or not. Note that there may be random errors mainly due to friction, and you may encounter that the weights needed to balance the system may change by a few grams. You can estimate them by repeating the measurements several times. In the end, you should be able to answer whether your measured values are consistent with the result that you got from graphical and numerical methods.